For e-commerce companies, it is very important to understand their customer behavior and to predict which of their customers would result in churn in future. Because to keep the constant revenue, it is very important to retain your current customers and keep gaining the new customers as well. Hi guys, my name is Rohit, and in today's video, we would build customer churn prediction model using machine learning. Let's get started. Okay, so we are getting started with the project. So at the top of the project, we are just importing the packages and libraries that we need for building this machine learning model. Now let me talk about the data. So the problem statement that we have is customer churn prediction in case of e-commerce domain. So we want to predict based on the customer behavior whether this particular customer would churn. So what is meaning by churn? So churn means the customer would stop using the platform. So we want to predict such kind of a customers, because if you are able to predict that, we might be able to handle those customers better. We might be able to provide them better customer service, and we can try to retain them. So that's why it is very important to predict the customer churn for e-commerce companies. And I think it is applicable for all other companies as well. Now the data that we have is customer ID. So this is the unique identifier for every customer. Then we have information about tenure. So this is basically the duration in years for which the customer has been associated with the platform. Then we have information about the preferred login device of the customer. So this is related to the device which customer is using for logging into the e-commerce platform. Then the tier of the city where the customer is living. So it can be tier 1, tier 2, any kind of a city. So this is the information regarding distance between warehouse and the home of a customer. Because for example, if the customer is living near warehouse, he or she might be getting the orders delivered on time and might be like a happy customer. So this is again a potentially important feature. Then the information about preferred payment mode of that customer. Then what is the gender of customer, number of hours the customer is spending on the app, then how many number of devices are registered by that customer on the platform. Then what is the preferred category of ordering the product? So which types of product the customer is ordering more. Then what is the satisfaction score based on the feedbacks received from the customer? So what kind of satisfaction score the customer is having. Then whether the customer is married or not, we have information regarding that as well. Then how many number of addresses the customer is using for delivering the product. So that is again another important information. Then has customer lodged any complaints in the past? So that is important feature which we have. Then how is the order behavior? So is the number of orders, or let's say the amount of order, increasing over time or it is decreasing over time? So that information also we have. Then number of coupons the customer is using. Then how many orders the customer has placed till now. Then dates since last order. So how many days since the last order? So generally people who are churn or people who are not able to or not going to return to our platform, you would see longer duration between the orders for them. And amount of cashback received by the customer. So we have all this information regarding every customer, and we also have a churn column which would indicate whether the customer is going to churn or not. So 1 would indicate the customer would churn. So basically customer would leave the platform. And 0 would indicate that it's a happy customer, the customer is going to continue with this. So this is the information we have now. Now using all this information, we want to predict the churn, and we are going to do that using machine learning model. So first of all, we are reading the data from the CSV file. So I'm using the read CSV function from pandas for doing that. This is the data we have: customer ID, tenure, preferred login device, is it mobile phone or computer, the tier of the city, warehouse to home distance, preferred payment mode, is it debit card, UPI or credit card, gender of the customer, hours spent on app, then how many devices are registered, then what is the preferred order category, is it laptop, mobile or fashion or something else, what is the satisfaction score of the customer, what is the marital status, so is he or she married or not, number of addresses, complaints, order amount, hike, whether the customer is using coupons or not, what is the order count, days since last order. So we have all this information basically in the data that we have, and we are going to predict the churn column, which would be either 1 or 0. To start with, we would do the exploratory data analysis to understand the data. So if I use the info function on the data frame, I would get the basic information about the data frame. So df.info, this is giving me the basic information. So in customer ID, so in total we have data about 5,630 customers. So customer ID, all the values are non-null. Then in tenure, there are some customers for which we have missing data. So all these data types we have basically. And if I use the describe function on my data frame, I would be able to know now some basic information. So for example, tenure, the minimum tenure is 0. So basically the new customer, and the maximum tenure is 61. And the average is 10.1. The city tier can be anything from 1 to 3. Warehouse to home distance, the average distance is 15 and it can range from 5 to 127. So like this, we have information about every feature. So if you go through this, you would be able to understand how every feature is distributed. Now let's check if we have any missing values. So what I'm doing is I'm using eachNA function on the data frame in which we have our data, and then calling a sum function so that we get how many number of data points are missing in every column that we have. So basically in tenure, we have 264 missing values. In warehouse to home, we have 251 missing values. And similarly, there are other columns where we have some missing values as well. So before we build machine learning model, we'll have to impute these missing values. So we will do that later. So in terms of the percentage, almost 5% of the data is missing in tenure. Similarly for warehouse to home, and for other 4 columns as well, around 5% data is missing. So generally what I recommend is, if you just have 5 to 10% of the data missing, right, you can use simple mode or median imputation based on the type of data that you have. But if you have say more than 10%, 20% data missing, and that column is really important, then when you do the missing value imputation, you can think of any other method apart from this simple imputation method as well. So these are the columns in which we have missing values. Okay, so we have just listed down those columns over here, and we are going to do the missing value imputation. So what we are doing is we are imputing the missing values using the median value of the respective column. So we are using the median imputation for imputing the missing values. So after we do the missing value imputation, if we check how is the missing data now in the data frame that we have, so the percentage of missing values is now 0. Because all the columns in which there was missing value, we have imputed those missing values using the median value of the corresponding column. Okay, now here I am just checking different unique values that we have in every column. So customer ID obviously would have a huge number of unique values because every value is unique in itself. Then in tenure, these are the unique values which we have. So preferred login device, so it can be mobile phone or computer. City tier, the person can belong to tier 1, tier 2 or tier 3 city. Preferred payment mode can be debit card, UPI, CC, cash on delivery, e-wallet, again cash on delivery or credit card. Gender, female or male. Then number of devices registered, we have 1 to 6 number of devices registered. In terms of the order category, we have important categories here. So we have laptop and accessory, mobile phone, others, fashion and grocery. Then this is the customer satisfaction score. In the marriage information, the person can be single, divorced or married. Then we also have information regarding whether they have raised any complaint in the past or not. So all this information we are getting in the data. And the churn column, it has only 2 unique values, 1 or 0. So in terms of the preferred login device, most of the people are logging using mobile phone. So out of the 5,000 odd data points that we have, 2,700 people are using mobile phone for login. Some people are using computer, and again some people are using phone. Now in this case, phone and mobile phone is the same thing. Okay, it's just the different way in which data is represented. So what we would do is, in the preferred login device column, we would change the phone value to mobile phone. so that we are able to handle the data, handle the feature in a right way. So what we are doing over here is we are replacing phone with mobile phone, and that operation we are doing on the preferred login device column. So in the preferred login device column, we are going to replace phone value with mobile phone so that we get the consistent category. So after doing this replace operation, now if we check the category within the preferred login device, we are getting just two categories: mobile phone for almost 4,000 people and computer login for 1,600 people. So this would help us in using the features in a right way. Otherwise, we would have to create separate features for phone, computer and mobile phone. But these two categories are same. So it is better to merge them. Similarly, now what we are doing over here is in the preferred login device, we have information about mobile phone and computer. So we are now replacing mobile phone with 0 and computer with 1. So this would basically help us in creating a feature, because when we want to build a machine learning model, we want to convert these categories into numbers. So we are mapping mobile phone to 0 and we are mapping computer to 1. So we are now already having preferred login device information in the form of feature. Now with respect to the payment mode, these are the different payment modes customers are using: debit card, credit card, e-wallet, UPI, cash on delivery, CC, and again cash on delivery. So basically this COD and cash on delivery is the same. CC is credit card, again CC and credit card are same. So it is very important to merge these categories so that again we are considering the features in a right way. So what we are doing is we are mapping CC to credit card now, and we are applying that mapping on the preferred payment mode column. So df in square bracket the name of column dot replace operation. So wherever we have CC in this column, it would be replaced by credit card. And after that, if we check the unique values, you would see that now we don't have the CC category, but the customers with CC are now added into credit card. That's why for credit card now we have 1774 customers. And we are doing the same operation related to cash on delivery as well. So we are replacing cash on delivery with COD, and we are applying that replace operation on the preferred payment mode column. And after we apply that replace operation, you would see that now cash on delivery customers are 514, because we have added COD and cash on delivery into single category. So this is very important, guys, before you build machine learning model, because if you do that, you would be using your features in a right way. Now with respect to gender, we have male and female gender. So we are just replacing male value with 0 and female with 1. So this is again to convert your categories into numbers for using them as a features. Then preferred order category. So in the preferred order category, again we have different kind of devices: laptop, mobile phone, fashion, mobile, grocery and others. Now again here mobile and mobile phone is the same thing. So we are going to merge these categories. So we are mapping mobile to mobile phone, and we are applying that mapping on the preferred order category column. So after we do that, if we check the count, you would see that we won't have mobile category now. Mobile category was having 809 customers, right? So that has now shifted to the mobile phone category. So now instead of 1271, we have 2080 customers, which are mainly buying mobile phones. Okay, in terms of the marriage category, the unique values are married, single and divorced. And churn, so around 4,600 customers are going to continue. So the label for them is 0, and around 950 customers, their label is 1. So these are the churn customers. So before we build the models, let's visualize the numerical columns and see what kind of patterns we are seeing. So on the x-axis, everywhere we have the churn value, so whether the customer would churn or not. And on y-axis, we have the numerical features. And we are creating a box plot here. So we have created a figure with 4x3 matrix such that we can create in total 12 plots. And for every numerical column, we are checking its box plot with respect to the churn column that we have. So for example, tenure column. So on x-axis, we have churn. On y-axis, we have tenure. So here churn 0 means this customer has not churned, and churn 1 means this customer has left the platform. So basically, if you see, what we are doing is like for churn 0, the average tenure or the median tenure is 10. For churn 1, the median tenure is very less. So by seeing this box plot, we can say that customers which are with platform for a longer duration, there is a low chance that they would be churning in future. Then if you check number of devices registered. So for customers who have not churned, the number of devices registered are 3 to 4. But there is lot of variation in customers which have churned. So they have large number of devices registered on the platform. So like this, you can go through every box plot and try to understand if there is any pattern related to that variable. Now let's say dates since last order. So for example, for customers which have not churned, you would see that there is lot of variation with respect to dates since last order. But customers which have churned, they are within some range, but there are a lot of potential outliers as well. Now, if you see these data points, these are still potential outliers. We cannot say that whether they are definitely outliers or not. So when you work in the industry, usually what I recommend people to do is you discuss with your stakeholders, discuss with subject matter experts that I'm getting these values in this feature. Do you think it's a value which is expected or it's kind of an anomalous value? Then you can try to remove it. So on the categorical side, basically we have these three features: preferred payment mode, preferred order category, and marriage status. And on the numerical columns, we have multiple columns which are going to provide us information. So this is the data we have. So if we see now this data frame, all the columns are in the form of numbers apart from these three columns on which we would have to create dummy features, but all other columns are in the form of numbers. So let's create the features from this data and let's divide our data into train and test set. So I'm calling train test split and features function over here. So this is the function basically. So our y variable or the value that we want to predict would be churn, and our x variable or all the features would be in our df features data frame. So I'm dropping churn column from that because obviously we shouldn't use the column that we want to predict as feature. And then we are applying the get dummies function basically on the data frame that we have. So what this would do is this would convert our data into a dummy feature specifically for the three columns for which we want to create dummy features. And after that, we are just doing the train test split. So this would split the data into training set and testing set. So training data we would use for training the model and test data we would use for evaluating the model. So after we do this, this is how our data would look like. So if you see, the numerical columns are as it is, but the columns for which we wanted to create a dummy variable, so we have created that dummy variable. So this is preferred payment mode UPI, preferred order category fashion, here preferred order category grocery. So we have created the categorical variables based on the specific category that we had. So we are now left with 28 features because we have created additional features based on every category column that we have. So if we check the training data frame now, if we check the top 10 rows, this is how the data is looking like. So all the data points are in the form of numbers. So basically our data is now ready for training a machine learning model. Okay, so what I'm doing now is I'm calling the fit and evaluate model function, which I have written over here. And to this function, I'm passing our training features, testing features, and then training labels and testing labels as well. So this is our fit and evaluate model function. So we are first of all initializing a random forest classifier. So here we are initializing the random forest classifier. We are keeping max depth 5, mean sample split as 0.01. So this would decide what's the percentage of samples which should be present to decide whether to split the decision tree further or not. Then what's the maximum features we want to use in every node. So we are passing 0.8. So only the 80% features would be used. This is related to feature bagging, and max samples we are using 0.8. So only 80% of the data points would be used. This is related to data bagging. Okay. So basically we are fitting the random forest model now using the fit function, and we are passing our training features and training labels to it. And then based on the model that we have trained, we are going to predict. So we are creating the prediction over here using the predict function. So this would predict for every test data that we have, what is the label. whether the customer is going to churn or not. And after that, we are creating the bunch of evaluation matrix. So basically confusion matrix, accuracy score, classification report. So all those things we are calculating and printing. So based on the results and based on the data that we have, this is the confusion matrix that we are getting. And the overall accuracy of our model is 88.54. So this is class 0, which is related to the customers which have not churned. So for class 0, we are getting F1 score 0.93 and the recall value is 0.95, precision is 0.92. And for churned customers, we are getting 0.62 as the F1 score. So it is not as good as class 0, but still it is really good considering we had imbalanced data. So if you check the churn versus non-churn, so we have almost 5 times customers which have not churned. So only let's say 15 to 18% customers have churned overall. So model is still doing well with the parameters that we were sending and the kind of features that we have. So after you do this, you can try feature parameter tuning as well. So what you can do is you can try different parameters with respect to max depth, mean sample split, max features and max samples, and use grid search CV and see which are the parameters for which you are getting the best results on this data. Now grid search CV is going to try cross validation. So here I am setting CV equal to 5. So this would try 5-fold cross validation. And I am again initializing a random forest classifier here and passing it as an estimator to grid search CV, passing it parameter grid which it should try. So this is the grid which we have created. I am saying cross validation should be 5. So it is going to try 5-fold cross validation. So it would divide the data into 5 data sets, and in every iteration 4 data sets would be used for training and the rest of the data set would be used for evaluation. So you would see all the matrix printed over here. So overall, after we run this grid search code, we can save all the results that we have into a data frame. So what I'm doing here is search.cv results. So this would have all the results for every set of parameters. We are storing that into results data frame, and I'm just sorting the results data frame based on the mean test score. So what is the average score that it is getting on the test data within the cross validation, and I am keeping it in the ascending order so that we get the top result. So if I scroll to the right here, the top result that we are getting is 0.91 with respect to accuracy, and it is for max depth 10, max features 0.7 and the other parameters as well. So if you want to see which is the best parameter that you are getting after applying grid search CV, what you can do is you can do search.best params. So that would give you the best parameters on your data set. So on this data set, the best parameters that we are getting are max depth 10, max features 0.7, max samples 0.0 and minimum sample splits 0.01. So now what we would do is we would use these best parameters and train our machine learning model on complete data, because in cross validation it was using only 4 folds for training and 1 fold for testing. But now we would use complete training data for training the model based on the best parameters that we have found using cross validation. So this is what we are doing here. We are again now calling fit evaluate model function, which we have written over here. We are calling the same function, but now we are passing the specific parameters which we have found. So we are saying we want to keep max depth 10, mean sample split 0.01, max features 0.7 and max samples as 1.0. So after we do this, this is the result we are getting, and now the accuracy that we are getting is 90.31. So previously the accuracy that we were getting was 88.54, and for class 1 the F1 score was 0.62. Now the F1 score that we are getting is much better. We are getting 0.68 as the F1 score. So after we applied this hyperparameter tuning, we have improved the result. Now when we are working in the industry on such kind of problem, what you can do is you can also change your decision threshold. So this result is based on default probability threshold of 0.5. But you can say that let's say any customer for which probability is higher than 0.4, that customer has a chance of churn. And then that would help you in improving your recall value. So this is how you can play with the threshold of the probability as well. And after I build the model, I have identified which are the features, which are important features getting used in this particular model. So you can do that using model.featureImportances in case of a random forest model. So here I am just creating a data frame in which we are going to store all the feature names and the corresponding importance score. And after I do that, I can just create a plot which makes it easy to read which feature is the most important. So if you see here, the feature tenure, we are getting the highest importance for it. So this is the relative importance of the feature. Then feature complaint is also important. Cashback amount is also important feature. Number of addresses is also important feature. So based on these feature importances, you would know which features are actually contributing to your overall result. Now, if you want to make this better, you can also try other methods like, let's say, SHAP, which would tell you for every individual prediction which features were important in making that prediction. So you can try that as well. I hope that now you got clarity in terms of how we can use machine learning in e-commerce domain or in any domain for predicting the chance of churn. Now this churn prediction problem is applicable in financial or banking domain as well, because even there you have large number of customers. So wherever there are large number of customers which we want to retain over time, we can use their historical data and build churn prediction model, so that the customers which have higher probability of churn, we can handle them in a better way to increase the customer retention rate. So try to build those kind of problem statements now on your own, and that would give you better confidence. Thanks for watching the video, and I will see you in the next one. Bye bye.